Good evening, everyone. Tonight we're going to be discussing the surface area and volume of pyramids, cones, and spheres. First, let's talk a little bit about pyramids. So a pyramid is a polyhedron in which the base is a polygon and the lateral faces are triangles with a common vertex. So the vertex of a pyramid, that's that common vertex, it's where the triangular faces meet, and it's always across from the base. A regular pyramid is a pyramid with a regular polygon base, and the segments joining the vertex to the center of the base is perpendicular to the base. So that means we've got a regular polygon for the base, and that the common vertex, the vertex of the pyramid, is centered exactly over the center of that polygon. Now here's a new term, slant height, and then you'll see here I've got a little cursive L. Slant height is always written with the cursive L. So the slant height is the height of a lateral face of the regular polygon. So it's the height of one of my triangular faces, which is different than the height of the whole pyramid. And so then our lateral area is the sum of the area of the lateral faces only. So it's the sum of just the triangular faces, not the base. Now let's discuss a few formulas. So we have formula for lateral area of a regular pyramid. So my lateral area is 1/2 PL, where P, big P, is the perimeter of the base, and then L is actually my cursive L for slant height. So that's again the height of one of the sides, not the height of the pyramid. And then for total surface area, we have to use our lateral area plus we have to add on that base. So my surface area is big B plus 1/2 PL. Well, where big B means what it meant before, so area of the base. Now let's talk a bit about cones. So a cone is a solid with a circular base and a vertex not in the same plane as the base. So basically, cones are just like pyramids with circular bases. Now a right cone is a cone such that if I drew a segment joining the vertex and the center of the base, that segment would be perpendicular to the base. So here, meaning my vertex was directly centered over the center of my circle, the base circle. Now let's look at a few formulas. So first we have the formula for lateral area of a cone. So just like how prisms and cylinders had a very close formula, cones and pyramids have a very close formula. So I know that my lateral area of a pyramid is 1/2 PL, but I know that P, my perimeter of a circle, is my circumference, so I'm going to replace that with 2 pi r, so that gives me 1/2 2 pi r L. And then the 1/2 and the 2, well, that cancels just to be 1. So then my lateral area of a cone is pi r L, where L is, just like with a pyramid, the slant height. Now for total surface area, I have to use my lateral area plus my base, so that's going to be B plus 1/2 CL, which is the same as pi r squared plus pi r L. So again, note these are just like my pyramid formulas, just plugging in C for circumference and then area of a circle formulas. Now let's talk about volume. So I have volume of a pyramid, so it's 1/3 big B times height. Well, that height is the height of the pyramid, so it goes from the vertex at the top straight down perpendicular to the base. And then for a cone, similar to a pyramid, it's 1/3 big B times height, but big B is pi r squared, so it's 1/3 pi r squared height. Now you'll notice that both of these are 1/3 of, like a pyramid is 1/3 of a prism, and a cone is 1/3 of a cylinder. And remember, height is the perpendicular distance from the vertex to the base, and it will be inside of the cone or pyramid, and it's not the same as a slant height. Regular height and slant height are not the same thing. So now let's talk a little bit about spheres. So a sphere is a set of all points in a space equidistant from a given point. So here, instead of a radius just going to the edge, my radius can go anywhere inside of my sphere, and it has to be the same. So the radius is the segment from the center to a point on the sphere. Again, it can be anywhere on the sphere. It doesn't have to only be like flat in the center. A chord is a segment whose endpoints are on the sphere. So here my chord, it just connects any 2 points on the sphere. It does not have to go through the center, where a diameter is a chord that does contain the center. So it connects 2 points on your sphere and it goes through the center. Now the surface area formula for a sphere is 4 pi r squared. And there is only total surface area for a sphere. There is no lateral surface area because there are no lateral faces on a sphere. Now let's talk a little bit about volume. So first, if we have the intersection of a sphere and a plane, so just like we were doing cross sections before, it actually creates a great circle. So a great circle is a plane intersecting a sphere that contains the center of the sphere. So it's this circle in the middle if you slice the sphere right through the center. And then those two slices are called hemispheres. So they are the congruent halves of a sphere separated by a great circle. And then lastly down here, I've got my formula for volume of a sphere, which is 4/3 pi r cubed. Note this one is the only one that has a cubed term in it. And that is everything I have for you tonight. See you in class.